Hello everyone, I hope you're doing well. So in this video, we're going to discuss Geeks for Geeks problem of the day, and today's problem is Bheem wants Ladoos and it is a medium level problem. So this particular problem says that, so I'm just going to summarize the problem. So essentially we have been given a binary tree and we have been given a source node. So let's say 9 is a source node and you can see they have denoted it as home. Now we have also been given a value k. Since k is equals to 1 here, now we have to consider all the nodes which are at a distance 1 from it. So if by 1 I mean all the nodes which are at a distance 0, then 1 and then so on. So if the value of k is 3, so all the nodes at a distance 0, then 1, 2 and 3, all those nodes will have to be considered. Right. So we have to consider all the nodes up to distance k and we have to find the sum of all those values. So this is essentially the whole question. Now let me just show you with this particular example because the value of k is different here. So let me just copy this particular sample test case. So as you can see, the home is 40. So I'll just construct the partial tree. So 2 is here, then 4 is here, and we have 8, then we have 30, then we have 19, and we have 40, and then we have 50. So all the nodes which are at a distance up to k is equals to 2 should be considered. So if you consider the first node, that is 40, the home node, then it is at a distance 0. Now this node is at a distance 1 from 40. This node is at a distance 2 from 40, and again this node is at a distance of 2 from 40. Now I cannot go to any other node. These are the only nodes that I can consider. Right. So I solved this problem with a very intuitive idea. The idea is very simple. What we can do is we have been given a tree, but we can easily convert this tree into a graph. So let's say I have a simple graph and I have a source node. Right. I have a simple graph and I have a source node. Now to find out the distance of every other node, I can apply simple BFS. If I apply simple BFS to it, I'll get all the nodes at a distance 0, then 1, then 2, and so on up to k. And I can just sum the value of all those nodes. So you see, like, the idea explanation is this much only. This is the whole idea of the problem. So what you can do is you can convert the whole tree into a graph. Now once you have got a simple graph, you can simply apply BFS on it and you can just sum all the values. So while applying BFS also, we'll discuss the details later. And before discussing about the BFS part, let us discuss how can we convert this particular tree into a graph. So you see every node. So for example, if I have a node here, I can have 3 connections to it. So one connection will be with the parent. So this is the parent of the current node. Now the second connection can be with the child, and the third connection can be with child. So this is, let's say, child 1, this is child 2. Right. Now these are the maximum 3 connections a node can have. A node cannot have a parent. Say, like, for example, the root node, they don't have a parent. A node cannot have either child 1 or child 2, or it cannot have both of them. Right. It can be the case. But the maximum number of nodes any node can have, or the maximum number of connections any node can have, is 3. Right. So what I can do is I can start traversing from the root node. Right. I can start traversing from the root node and I go to every other node. And for each of the nodes, I check whether my parent is not equals to null. If it is not equals to null, then what I'll do is I'll just insert graph of current. I'll insert, let's say this is pushback, graph of current, pushback parent. Right, this is what I'm going to do. I check whether the left child is null or not. If it is not null, I'll do graph of current. So this is the current node. And what I'll do is I'll push back the left node. So I'll push back left to it. Right. I'll check whether the right node is null or not. So what I'll do is graph of current. If the right node is not null, not push back right. Right. So these are the 3 steps I'm going to follow. So after we have constructed a graph for all the nodes, while traversing through the tree, there is also one more thing that I need to take care of. Among all the nodes, there will be at least one node for which the value of home is equal to the current node. For example, in this particular case, the value of home in the sample test case, the value of home was 40. So there was one node with the value 40. this will be considered as our home. So whenever we encounter a node with the value 40, what we can do is we can mark it as a source. So source will be equals to current node, right? So this is what you have to do. Since we will be using BFS and we will also be using a distance vector while traversing through, so let's say this is the distance vector. While traversing through a tree, if the current node is the home node, then we set the distance of current, let's say this is current as 0. Otherwise, we set the distance of current as infinity, right? Because we will need this distance vector later. So now these are all the information that we have to process while traversing through the tree, right? So once we do this step, we know that we have got a simple graph and we know the source node. We just have to use single source shortest path, and we have to consider all the nodes which are at a distance less than or equal to k, right? So the BFS will also be very simple. The only difference will be whenever you call for the children of the current node, you have to make sure of one thing, that the distance of the current node should be less than k. Why am I doing this? Because as soon as the distance of the current node becomes k and you call its children, so for example there is a node that is at a distance k. Now if you call its children, any of those children, then the next node would be at a distance k plus 1. So this is not what we want. We only want nodes up to a distance of k. So we don't want to process any other thing more than this. So as long as the distance of current is less than k, only then we will be calling all the nodes attached to it, or we will be pushing them into the queue, right? So this is the whole idea of this problem. The idea is very simple and intuitive. What you can do is, I'll quickly summarize. Since we have got a tree, now what we can do is we can convert the whole tree into a simple graph, and the conversion process is not also very difficult. You just have to traverse through all the nodes, push all the 3 connections if they exist. So a node can have maximum 3 connections, right? So like whichever of them exists, like we can just push them into the graph. And the next step is to maintain the source in the source variable and the distance vector. So whenever the current node is the home node, then we set the source as current and distance of the current node as 0. Otherwise, we just set the distance of the current node as infinity. Right. At the end, we can just do simple BFS stuff, and we have to make sure of one thing, that we only call the node attached to the current node only when the distance of the current node is less than k. The reason being simple: if the distance of the current node is equals to k, then the next node will be at a distance of k plus 1. This is not what we want. We don't want to consider this particular node. And while doing the BFS, we can keep adding the value of the nodes into our answer variable, right? So this is all we have to do. Now let me just show you the code. So here's the code. What I have done is I've initialized my infinity variable as 1e9, right? So now I have a distance map. So I'm using maps because I don't know what will be the value of this node pointer. So the first part is node pointer and the second part is integers. Again, I construct a graph with the first part as node pointer and the second part as vector of nodes, right? Now what I do is, so this is like adjacency list representation. It says that I'm using a map instead of a double dimensional vector. Now I just set my source. So I have initialized my source variable. I have not set its value, but I have just like marked it as that I need this variable later on. So this is my traverse function, and I'm calling this traverse function here. So the first value that I pass is root and null pointer. So the first variable is current, that will be representing the current node, and the second variable is parent, right? So the parent of the root node is null. So if the current node is itself null pointer, then I can just return from here. Now if the parent is not equals to null pointer, right? That means the parent of the current node exists. What I'll do is I'll just push back the parent into the graph of current. Similarly, if the left node exists and it is not equals to null pointer, I just push back the left node into the current, right? Similarly, if the right node exists and it is not equal to null pointer, I'll push back the right node into graph of current, right? Now if the data of the current element is equals to home, so home is the value that we require, right? Now we will set the distance of current as 0 and source as current, right? Again, if it is not true, then obviously the distance will be considered as infinity. Now I just do the same thing. I just call the traverse function into the left part, passing the parent of the left child as current, and similarly I just call the traverse function on the right. Now I initialize a queue and I push my source into the queue, and I have initialized my answer with 0. So this is the last part is very simple BFS stuff. What I have done is I have just checked while the queue is not empty. I just pop the current of the front element of the queue and store it into my current variable. Now I just add the value of current into my answer and I check if the distance is less than k, distance of current is less than k. I traverse through all the childs, and if the distance of the child is greater than distance of current plus 1, then I update the distance of the child and I push the child into my queue. So this is all what we will have to do, right? So after all of this has been completed, my final answer will be stored in my answer variable, so I can just return my answer. So this was all about today's problem of the day, that is Bheem wants Ladoos. I hope you guys were able to understand the solution. If you guys did, then consider dropping a like on this video and don't forget to subscribe to this channel. It's always free of cost, and if you don't find the videos interesting later, you can always unsubscribe. So don't forget to share the channel with your friends. Until the next video drops, keep coding, stay safe, bye bye.